So I'm basically going to go over some polymorphism and inheritance. They're kind of tied together. So I guess the first thing is inheritance, and then what inheritance gives us is polymorphism, right? Um, so I've just kind of hacked up a vehicle class here. So this vehicle class is going to represent a abstract base class, and we know that because there are virtual keywords in it. So we can't actually have a concrete instantiation of this vehicle class. And by concrete instantiation, what I mean is we can't do something like this. It's going to kind of yell at us or should. And it's basically not allowed because there's pure virtual functions and they're not defined, right? Um, and this is good because we don't want to be able to make a concrete implementation of that because it doesn't have anything filled out. Um, so vehicle is going to kind of remain as this abstract base class. We are going to make classes that inherit from vehicle is how we're going to do this in the code. So we can just kind of walk through the vehicle class. So everything is public. I just chose to make everything public for this situation. We have a cost, so that's going to be the cost of the vehicle, and then we have a name, the name of the vehicle. Uh, we have a virtual destructor. So most of the time when you are inheriting stuff, the compiler is going to require you to have some kind of destructor defined, even if it doesn't do anything. In which case, this one quite literally doesn't do anything at all, and that's okay because we don't have any new memory. We don't need to actually delete anything. So, but it will sometimes require that to be in there. So you might as well put that in there. When we have virtual functions like this, we can just set them equal to 0. This is totally acceptable syntax, and this is what you should be doing, similar to this virtual function here as well. So we have a display cost function. So this display cost function you can see is actually defined. What this means is any class that's going to inherit from vehicle is also going to be able to use this display class. So, for instance, we have a car and a truck that are going to inherit from vehicle, and they're going to be able to call this display cost function, and it will do this. And it will print out the name and the cost of the vehicle. This right here, this is a virtual void set cost function. So this is just a setter, but it's virtual and it doesn't have a definition. So basically the way I've designed this is that it is the car and truck, the inheriting classes responsibility to actually define this cost. Okay. Um, so they're going to be in charge of actually defining what the cost is. And so we'll see that implementation down later. And then 19, there's a set name function, which is similar to display cost is defined within the vehicle itself. So that set name belongs to the vehicle so that we can actually set the name variable. Now, these are public, so technically there's no real need for the set name function. We could just set it directly, but I threw in a function in there just so we can actually see what that looks like. Cool. So let's see if there's anything else in there. One thing to mention with anything that's virtual is basically anything that's inheriting from vehicle, it's going to be their responsibility to create that set cost function. So that's one of the key takeaways from this is just that if it's not defined out here, it better be defined out in the child class, right? Any questions on the setup of the vehicle? Okay, cool. So let's see here. There is a car class. So now this is a child class that is inheriting from vehicle, right? So we're making everything public once again. I'm going to create a constructor for this class. It's just going to set the cost to 0. It could also set the name to nothing if it wanted to. Probably smart to do that, to be honest. So we can just set this to like NaN or just like a blank string. This name again is the name that's actually defined here. So everything that inherits from vehicle is also going to inherit these variables. So hopefully that was clear as well. And then here we actually have to define this set cost function, right? Because it's not defined in the parent class, so we have to do it here. And the reason I designed this so that the inheriting classes have to set the cost is because arbitrarily I just set that the cost of certain items were going to be different based off of the type of vehicle it is, right? So let's kind of compare the difference between the truck and the car's set cost function. So both of them take in the same parameters, right? The number of doors and the engine type, whether that's like a four-cylinder V6 or a V8. So those are the parameters there. Um, and basically, I reset this cost to zero in case they try to reset the cost. I don't want the cost to keep incrementing every time the set cost is called. So I just reset that to zero. Um, but based on the number of doors that are passed in, there's some arbitrary unit, 5 that's multiplied by doors and 10 multiplied by the engine type. If we go down here to the truck, we'll talk about towing capacity in a second, but you can see that the doors are what seems to be a little bit more expensive on a truck, and the engine is going to be more expensive on a truck. Again, this isn't super important. It's arbitrary values that I picked, but what is important is to see that these are actually defined in different ways, and they're going to be doing different math operations on the parameters that are passed in based off of whether it's a car or whether it's a truck. So now looking at the truck, we can see there's also towing capacity. So while cars, typically have some sort of towing capacity, most people buying cars aren't asking what the capacity for the towing is of the car, right? It's more of like a truck thing. So here we actually are able to set a towing capacity. And what I want to make clear here is that this towing capacity is only specific to a truck now, right? A vehicle doesn't understand what a towing capacity is, and we'll kind of go over that when we talk about downcasting and upcasting. But this is very specific to a truck itself, right? And it should be a vehicle. I guess in this scenario shouldn't really have a towing capacity because we don't want a car to have a towing capacity. And then with the set cost function, we actually take that towing capacity into account with the cost of the vehicle. And we also have a setter. Again, even though this is public, we don't really need a setter. I've put one in there anyways, just so we can see different function calls with inheritance. Any questions on the way I've defined these child classes? All right. Okay, so we can go down here to, I don't need this. I know. We can go down here to the main and actually see what's going on here. So I'm instantiating 2 different objects, a truck object and a car object. And then I'm going to go ahead and have a new truck and a new car. So the reason I'm making these pointers and making them dynamic is because later on I want to use some type of polymorphism. And to do that, I need these things to be pointers. That's just the way it works in C++. So we're gonna keep those as pointers. And then here I'm setting the name of the truck to just Tacoma, just the type of the truck it is, and the same with the car. It's just going to be a Jetta. So I also want to set my truck's towing capacity because remember that's a variable that the car doesn't have that I'm going to pass in here. And then for the truck, I'm also going to set the cost here. So this is the number of doors is 4, and the engine type is a V6. And then I'm going to push these back into a vehicles vector. So basically, actually, I don't actually want this set cost here for right now. What I do want is just to show you that these things are going to be zeroed out is the display cost function. So we can do that. So I'm going to go ahead and push these things back into a vehicles vector. This is where the polymorphism comes in, where basically having a vector of the yeah, what's up, Franco?
Sorry, real quick. Sorry to interrupt you.
No, you're good.
Question, right? So, like for example, when you create truck, my truck, or car, my car, right? You're creating the base class pointer, right? That the base class is going to be the truck, right? So, right? Does that mean can you access functions of classes that are derived from truck using the base class pointer or no?
So are you saying truck, my truck is derived from vehicle, right? So this is actually a child class of vehicle. So is your question, can we access like vehicle functions from my truck?
Yeah, we can access vehicle functions, right?
Right.
Okay. And
yeah.
But if something derives from my truck, okay? If something derives from my truck, would we be able to access those functions?
Assuming they're public, yes. Yeah, they would be able to access and I might be able to hack up an example like that once we get through this, but theoretically, yeah, they should be able to access like the set towing capacity if we wanted some type of like sub truck or something like that.
Like
Yeah.
a vehicle could access the truck functions, right? Even if that's my question, right? Like
Right.
let's
So
say that
that's where it gets a little bit weird, because a vehicle actually can't access the truck functions that the
vehicle does not have.
vehicle does not have, right? So we'll see an example in a little bit where we try to like it's called upcasting, where you
Yeah.
basically are going to try to set, or it might be downcasting, but basically we're trying to set a vehicle to a truck, and it won't know what to do with this set towing capacity because it actually won't have that function, because this set towing capacity and towing capacity variable itself is only in the scope of a truck. It's not in the scope of a vehicle.
Because vehicle is not a truck, but truck is a vehicle.
Exactly. Yep. Yep.
Perfect, thank you.
Yeah, no problem. Cool. Yeah, so basically we're gonna have a vector of vehicles here, and we're able to push back both of these, the my truck and my car. And even though they aren't a vehicle type, so while this looks kind of weird because you're like, wait a minute, my truck is a truck and my car is a car, I'm pushing vehicles. Both of these things inherent from vehicle, right? So basically, C++ will see these things as vehicles. And what we're able to do here is just go through 2 for loops through this vector. And I can call the set cost function on just a index within vehicles, and it will call the correct set cost function. So this will depend on what it's pointing to, right? So when I call the set cost function, I'll pass in 4 for the number of doors and 6 for the engine type. And we're going to see that when we call the display cost function, both of these things are actually going to cost different cost. And hopefully that proves to you guys that these two things are being called separately. And I can also print this statement in here just to prove kind of where we're at. So let's go ahead and run this. So what you can see here is this very first print statement I have, which is just in the display cost. We have the cost of the Tacoma is 0. And that's to be expected because we haven't set the cost at all, right? And then once we do the set cost and we go through this for loop for this display cost, we can see the cost of the Tacoma is 318, and the cost of the Jetta is 80. And that's basically based off the 4 and the 6 that I passed in and the math that is done to it. The display cost is a function that's provided in vehicle, and it basically knows the name and the cost based off of who calls this display cost. So it's all about like the this pointer. The this pointer, it knows that it is a car or a car or a truck, and it's able to properly gather which object it belongs to based on the this pointer. And that's kind of the even though this is an incredibly like simple example, this kind of is what polymorphism is, and this is what we mean by like different behaviors can change at runtime. And that sounds confusing until you kind of start working with something like this, where we might not know what the behaviors are because it's going to depend on what type of object it is and maybe what type of object like the user selects or something like that. Any questions on that concept there? Okay. So let's go ahead and I guess to drive this home super quick, let me actually print these out. So this is a car cost will be set when this car set cost is called, and then the same with the truck. So if I go ahead and make this, you can just see that this is the truck cost is being called when the set cost function is being called here. And then the same with the car. And the reason I was printing those out is just to prove to you guys that even though we're dealing with a vehicle vector, that it is going to choose the right functionality, right? That's like kind of the crux of this whole like polymorphism is relying on that. Okay, so let's see here. So let's talk about upcasting, downcasting a little bit. So doing something like this and then changing let's see here, my truck. So we're making basically we're instantiating a new object that is a vehicle. So it's not a truck or a car, it's actually a vehicle. And it's a copy constructor that is copying it from my truck. Okay. So what we can do here is copy truck and then paste it here. And everything should work the way we expect. Yep. So the cost is still 318 and $80. This definitely shouldn't have changed, but the truck cost is still 318. Um, the reason this is okay is this is considered upcasting. So this is allowed because a truck is a vehicle, right? So we're allowed to kind of shift in that direction, and these things can be kind of confusing because they almost feel opposite in your brain. But we're allowed to do this. The only issue that's going to crop up, and I'm going to use his PowerPoint real quick. Actually, this is the wrong one. Let me get polymorphism. All right. If I can pull this up, I think Fox's diagram is pretty solid. So this is something that we're doing right here, which is a upcast. So we're going from a truck. Let me show them both here. We're going from a truck to a vehicle, right? And in doing so, we know that the truck here has a towing capacity. Basically, that variable is just going to be completely ignored. Okay. So it's not going to be able to be copied over, which means if we try to access that variable from truck, it's not going to be there because vehicle doesn't have a towing capacity. So if we try to do like towing capacity, you can see it's not even coming up. And this is actually going to give us an issue because vehicle doesn't have a towing capacity. And this kind of ties into what you were asking, I think, earlier, Franco. But um, this is it's not necessarily an error because it lets you do this. It's just something that you definitely have to keep in mind when doing upcasting. What we do here is an upcast, right? So if we tried to do vehicles at I and then try to access the towing capacity, that's not going to be allowed, right? It's the exact same concept. So truly what we're doing here is some type of upcasting. And we need upcasting because that provides us the ability to do this polymorphism, right? Um, on the other end of the spectrum, you have something called downcasting, which just isn't going to be allowed. So downcasting is when you try to make a truck now point to a vehicle. Now, first we have to go up here and make a vehicle like actually able to be created. So let's go ahead and get rid of these virtual keywords real quick. I think I needed that declaration still. So now we can actually create a vehicle if we wanted to. And then this is called my vehicle. But the reason this isn't going to allow this to happen is because this is considered downcasting. And downcasting is when we go to the base class to the derived class. So we're trying to go from the truck to a vehicle. The reason it's not going to allow this to happen is based on this diagram here. It doesn't know what to do with the towing capacity. So when we're making my truck 2, my vehicle doesn't have a towing capacity, right? Vehicles don't have a towing capacity, only trucks do. So when a truck tries to change itself to point to a vehicle, it has a variable that it doesn't know what to do with. There's no, what he's talking about, there's no source for it. And so basically you're not going to be able to do downcasting at all. It's just actually like fundamentally not going to let it happen. That's kind of the concept behind those two things. So upcasting is allowed, downcasting is not. And definitely try to figure out in your brain like how you're going to picture each one because they can be confused pretty quickly. Honestly, if I didn't have these comments on here, I'd forget which one is which. So upcasting, just to go over it again, upcasting is when you're going from the derived to the base. So basically you are doing the child class, or excuse me, you're trying to instantiate a parent class based off of the copy constructor from a child class, right? So you're pointing a vehicle to a truck. You're pointing the parent to the child. Downcasting is when you try to point the parent to a child class instantiation. And I think why it gets turned about is because like upcasting, for instance, sounds like you're going like up in the hierarchy. But in a way, you're going up, but like to the left, if that makes sense. Like this is going up a hierarchy, meaning the truck is now going to become a vehicle, if that makes any sense. So try to figure out what makes sense to you, because it is important that you know the difference between each one. So, any questions on the upcasting and downcasting?
Yeah, I have a quick question.
Mm-hmm.
So, upcasting. Wait, sorry, I had to swallow real quick.
Yeah, you're good.
Upcasting is So we have the truck, right? And we're basically gonna make the truck a vehicle, right? We're gonna push it up to its parent class, right? We're gonna make it an instance of vehicle.
Right.
And if there's any functions that the truck has, after you upcast it, it says there on the slide that it gets ignored. But what does that mean? Like nothing happens. The function still remains there. Just there's no problems, or does the function actually disappear itself?
Yeah, good question. So the function like is still there in the sense that it still belongs to the class, but the object itself, truck, and let me rename this to like because that's like actually like a keyword. Cool. Truck. Okay. Um like in the sense that like the actual function for truck like set towing capacity won't just disappear for all the truck objects, but for this specific one for vehicle truck, because it now thinks that it is a vehicle because it just can't reference this
Okay.
um
So
at
basically,
all. Yeah,
yeah. So basically, it kind of loses its unique functions and just gets like the ones that the vehicle has or the
exactly.
base parent class has.
Yep,
Okay.
exactly. So it still can do the display cost and the name and the cost. It has all of these, and if we like, all of these attributes right here, all of these belong to
Vehicle.
vehicle, right? The cost, name, display, set cost, all that
Hmm.
stuff. Yeah, yeah.
Okay.
It's just that things that are specific to the truck, which is towing capacity and set towing capacity, you're not going to have access to. Yeah,
Perfect. Thank you so much.
yeah, no problem. Okay, so let's go ahead and we can make this virtual again. Uh, okay, cool. Yeah, so that is, I guess I can go, let me see here what I want to do. I can go over like kind of how the destructors work. Just to be clear, you're not going to need a filled out destructor for this lab. There's no dynamic memory that you should be dealing with. I mean, if you figure out a way to use it in the lab, like I'm not telling you don't, but I don't think I think it's going to be overkill for your lab if you're using any type of dynamic memory for lab 6. Um, so your destructor will basically just look like this for your shape class, where it's basically just filled out to nothing. But let's talk about if this did have some type of dynamic memory. And it's actually pretty straightforward. You just have to think of like basically who's responsible, who is like calling the new, and where does that pointer belong to. Okay. So if we make something in the, let's see how I'm gonna do this. Let's make something in the vehicle first, so we can have an int and then my pointer. This is going to be incredibly arbitrary. Um, and then let's say inside of the for whatever reason inside this set cost function, my pointer is going to point to a new int. Okay. Basically, we have to think here now, like, okay, who's in charge of actually deleting this thing? Um, and I would say basically delete the responsible party should probably be the base class, because this is where the actual pointer was defined. Now this is calling new, but this is where it's inheriting from. So what you can do here is basically just call delete on my pointer. Um, and then this should work out okay for us. So let's actually first don't do a delete and prove to ourselves that we actually have some type of memory leak. So let's do so we're losing 4 bytes, which hopefully makes sense because the integer is 4 bytes and we're creating one new one without any deletes, right? So if we call delete here and then run this again, we don't run into any errors, which is good. And then if we run the leak check, we're all freed up, right? So this is kind of how I would do it. Let's also make sure this works if like the truck also put one in there. So if there is a delete there, and make, and then let's do make sure we're leaking like 8 bytes, and then we can add this delete back in here. Okay, and that's all freed up. So hopefully those steps made sense. Basically, now both of these classes, like the car and the truck we're inheriting from vehicle, are both making a new integer at that pointer, right? One thing that I'll try to make clear is there might be some confusion thinking like, if this is a pointer, isn't it pointing, to the same dynamic memory in the car and in the truck? Like, don't they share that pointer? And so that's not going to be the case because when we inherit from vehicle, it creates an entirely new like instantiation of that vehicle, right? So it's going to be an entirely new like my pointer on the stack. It's not going to be the same like my pointer variable that's pointing at the same location. So that's one way to do it. The other way to do it is you could technically definitely make a destructor in here, uh, but I think you start to lose like actually who's responsible. And maybe I'm thinking about this wrong, but I would argue that you would want like wherever this is being created, like whatever scope this is in, that's who should be calling the delete. So while this will work, then you have to remember to actually put that destructor in both of these, right? Which I think is a little bit more upkeep, and I think that's why it's best to just because now we're writing two destructors for something that could have only been written like one time, right? So hopefully that's clear why it's probably easier just to keep this in the vehicle itself. Where this will change is if we don't have the my pointer defined in vehicle and we only have this defined in car, for instance. Obviously, there'd be no reason to have the delete in the truck, and hopefully this makes sense, is that it doesn't even know what my pointer is, right? Because again, this is just something that is specific to the car class and not the vehicle. So we can't even access the pointer there. And we couldn't delete it either in the vehicle class and the parent class because it also doesn't know what my pointer is. That is now only scoped in the sense of the car, which means it is definitely the car's responsibility to delete that. So really, like the dynamic memory, at least as far as like news and deletes, doesn't change too much. It's really just thinking about like what scope it belongs in, right? And just trying to write the least amount of destructors that you have to. The only time I guess you would write a different constructor different destructor for the car and the truck is if for whatever reason you were handling that memory in a different way. And again, that's the benefit of this inheritance, right? Is that if you wanted the car to handle its dynamic memory different than the truck, you could do that. It could be all separated out into the car, and it doesn't have to touch the vehicle, meaning it touches everything else. So, any questions on that? Like I said, that specific topic won't really come up in Lab 6. You don't really need to deal with that, but I think it's cool information to know. Cool. Okay, so let's go ahead and go over. That's pretty much it on the code. You can keep asking questions if you want, but that's actually all I had for you. We can go over Lab 6. So let's go ahead and open that up. Okay, so some of you may have already looked at this, but I'll go over it a little bit. So a lot of this is for you to read, so I'll just kind of go over the highlights on some of these things. So as far as the overview goes, this is going to be dealing with shapes. So you're going to have 2D shapes and you're going to have 3D shapes. And you're going to be using inheritance and the concept of polymorphism, which I just kind of went over. So hopefully polymorphism is starting to make a little bit more sense. He goes over a note about the pi and math functions. I'll leave this for you to read. Basically just tells you how to define pi so it works out well for the same numbers zyBooks gets. Here he goes over the like base and derived classes and what a like inheritance is. And then there is a relationship and a has a relationship. So something I didn't mention here is everything we're doing here, calling the virtual public. This is a relationship, right? This is a truck is a vehicle. If I went ahead and did private, this would basically mean it is a has a now. Where truck has a vehicle, which hopefully just thinking about that doesn't make a lot of sense. So it basically isn't going to this will like compile and work and everything, but like it fundamentally like doesn't make sense, right? We want the is a model, which would be public because truck is a vehicle. You will have some situations where you have a has-is relationship in this lab, but I'll go over that when we get there. So that's kind of what he's going over here. So he goes over this class hierarchy, which is important to know. So basically, you're going to have this abstract base class shape, and the shape 2D and shape 3D are also abstract base classes, and they're going to inherit from shape. So you have two things inheriting from shape, and then you have a square, triangle, and circle inheriting from the shape 2D, and a triangular, pyramid, cylinder, and sphere that are going to inherit from the shape 3D. So you kind of have like two layers of inheritance here, which it doesn't really get any more complicated. It's just another layer to kind of deal with. Um, Here, if we look at the class description, so this is for your shape class. You can see that both of these are virtual because it is a abstract base class, right? So you're going to have to define what scale and display do for your square, your triangle, and your circle. Okay, so basically the square, triangle, and circle, each one of those is going to have both of those functions defined. Similarly to how both the car and the truck defined what the set cost was, you'll have to do the same for scale and display. And then the same for triangular, pyramid, cylinder, and sphere. All of those are going to have their own scale and display functions. For the shape 2D, which is the second layer of abstraction, or excuse me, the second layer of inheritance, you're going to have two virtual functions, which is area and get name 2D. These two functions are going to be defined by all the shapes, right? The square, triangle, circle, triangle, pyramid, cylinder, and sphere. That's where the area and shape 2D are going to be defined. And actually, the get name 2D is this whole thing is specific to shape 2D, but it's got kind of the same concept as the 3D. You're just going to do volume instead of area, and you're going to do get name 3D instead of get name 2D. So those are also for all of the shapes to define. You'll see this one right here, show area, isn't a virtual function, which means it's actually going to be defined by the shape 2D. This is basically a function that your inheriting classes, your child classes of shape 2D, are going to share. They're going to use that same function. That's kind of the same concept here, where basically car and truck use the display cost and the set name function because those are actually defined in the class we were inheriting from.
Wait,
So
so
yeah, go for it.
I'm sorry, I'm always interrupting you.
No, you're good, man.
So when you have when you have a virtual function, right? When you have the virtual function, that means all the classes of that parent class need to define it themselves, right? But when
Right.
you don't have the virtual function,
Mhm.
you define it in the parent class, and then the child class have the same behavior, right?
Yes, exactly. Yep.
Okay.
Yep.
And then if I remember properly, we had on this class in a lecture, I think 2 lectures ago, and you can have like I forgot what the A was, but the ABC classes, right? So it's like is it arbitrary based class? And
Um,
it was
it's
something where like yeah, the abstract base class. But in the abstract base class, do you still define non-virtual functions or no?
so this is the same concept here. You can define let me see it. You
Oh,
can define some functions if you want to, I believe.
mhm.
Let's see here. So yeah, I think the biggest thing here, you can have information defined. You just can't create an instance of the abstract base class,
Okay.
which is like
Okay.
how the vehicle worked, where we weren't actually able to make a vehicle, right?
But you can still
Um,
create definitions that will be passed on to the child. Okay.
yep,
Makes sense.
exactly. Yep, yep.
Thanks.
Cool. Yeah, good questions. Um, okay, so I think yeah, that's basically what this will be. You'll have to define this within the shape 3D, and then similar for show area for the shape 2D. These functions right here, these operators look pretty intimidating, but they're actually the easiest thing in my opinion. You're basically just going to compare the area of the left hand side with the area of the right hand side and say whether it's true or false. This is a greater than, less than, or equals to, and then similarly down here for volume. So each one of those three functions should only be like one line. You can just return the greater than or less than, and then those will all be defined because same concept here. They're not virtual, so they're going to be defined within the shape 2D class. Same like how show area works. Um, okay, so get name 2D versus get name 3D. So This is kind of where he talks a little bit more about a is a and has a. But basically here you're literally just going to be printing out the name of the object. So if it's a square, you can just print out square. Triangle, just print out triangle here for the get name, or return rather, because these are getters. They're not supposed to return anything, so you can just return that string. Um, okay. Show area and show volume. This is just the just talking about defining it for with inside your 2D function. And this is basically what it's going to look like. You can just see out the get name 2D and the area. This is similar to the concept here where the display is basically displaying the name and the cost. Even though these are in this scope right here, if these were just functions called like get name and get cost, and car and vehicle defined those out, it will know which one of these to call for which object is calling the display cost function, right? So here it will know whether a square or a triangle or circle is calling the show area, and it will then call the correct get name 2D and get air, or excuse me, just area. So this is literally all you need in here, and he talks about that with the this pointer. So that's the concept there. And then it's going to be, he talks about this. It's the same concept with the shape 3D and show volume. It's going to look pretty much the same, just with the show volume function. Cool. This right here, he just goes over the mathematical expressions for your shapes. So if you don't know them offhand, he gives them to you. Cool. So the 3D shapes, I talked about how you're going to have something that basically kind of defines, or excuse me, uses a has is relationship. So it comes down into the three 3D objects, meaning these three right here: the triangular pyramid, the cylinder, and the sphere. Basically, within a triangular pyramid, it's going to it is a shape 3D, right? So you're going to inherit publicly from the shape 3D. And it also has a triangle. So the triangle comes up in the sense that it is the base of your triangular pyramid, right? A triangular pyramid, its base is a triangle. So that's where you're going to actually privately inherit from a triangle, because it has a triangle. So it has a triangle. And that's where you'll get that. And then similarly to the cylinder and sphere, you're also going to include privately from the circle, because both of those things are going to have a circle. They aren't a circle, so it's not a is a, but it is a has a. Cool. And then here he just talks about abstract base classes, which I kind of went over in the lab itself. So he talks about multiple inheritances and how some languages don't let you do this, but we can. So what you're doing here is multiple inheritance, right? Where you're inheriting a few levels down. So there's this situation called the diamond problem, where basically, like for instance, he gives a vehicle and a car, an airplane, which both are a vehicle, and then you have a flying car, but we're inheriting vehicle twice. So we're inheriting vehicle functionality twice. And you can basically just resolve this by putting virtual in front of your inheritance. And that's what I've done here is I've put virtual when I'm including vehicle. I don't think there is any harm in just putting virtual just off the bat, which is what I would typically do. Instead of thinking like, oh, is this going to be a diamond problem? I think you can just put virtual and you can just call it a day. So yeah, Franco, what's up?
Could you real quick repeat the has a thing? You said it's not an is a,
Yep.
but it's a has a.
Yeah. So this concept is kind of weird until you start working with it, and honestly, to this day, I'm still kind of wrapping my head around it. But it's basically the concept that you're not inheriting from them in the sense that you want all their functionality, as in like you are one of these things. It's a private inheritance, so you're only going to get basically the like public data from this thing. So you don't have the ins and outs of how this object works, which basically gives the functionality of the has a, meaning you aren't this thing, you have this thing. And I'm kind of struggling here to explain it, but
No, I
basically, if
feel like when you just look at it, like it makes more sense. You're like you're a what's called a pyramid,
yep,
but you want stuff from a triangle. So you're just gonna take they take like the functions and the identities of the triangle.
Right. Yeah. You like literally have a triangle object that you can call get area on and stuff like that. But what you don't have is access to like the private variables of triangle and stuff like that.
Mhm.
So, yeah.
Thank you.
Yeah. No problem. Okay. So public private inheritance. Yeah. So he goes over this again for some more reading for you guys. Um, let's see here. This is a situation where a car isn't an engine, so it just has a engine. So it does private, and then it talks about the only thing the car class has access of the engine object is the public member and functions. And then that's basically why you do it privately, because if you did it publicly, then you would be able to have all of the engines like private functions, which starts to become like you being an engine as opposed to you just having one. Um, so it's weird. It's kind of confusing, and I think the more you work with it, it'll make a little bit more sense. These are all considered like object-oriented principles, so OOP, and there's like entire courses taught like on these kind of concepts, not syntactically like this, but just like um, kind of the idea behind it and the design principles that go around it. So. Okay, accessing members of base classes. So this is kind of ties into this engine where basically if you have a engine, you can call the engine's get menu, like get functions with this syntax. So you basically just like scope it out. So for instance, for your triangular pyramid, when you need to get the area of the triangle, you can just do triangle like this right here, and then get area, and that's going to get the area of the triangle that you have. So that's kind of how that works. And then he talks about polymorphism, which is what I went over in class today. So I can let you read this. It's very similar to my example in the sense that he uses cars and some type of array. And then that each one of these like identities print out something different. And he can basically just call any of the indices identity, and it's going to print out the correct one. And that's an example of polymorphism. That's the best way to kind of explain it. So, and then he kind of brings the whole thing together and goes over. This is similar to what he's going to have in his main, so you can get an idea of like how these things are kind of being called. Cool. And then he goes over some tips. So that's pretty much it for this one. There's a lot of stuff that you'll end up reading. I kind of skimmed over this, but yeah, that's pretty much it for the lab. This one is challenging in the sense that you're learning how to inherit stuff, but the actual like functionalities are pretty simple, right? It's just like areas and volumes and stuff. So that's not really the hard part of this lab. It's just going to be learning how to work with inheritance and what the syntax looks like and all that good stuff, because it can get kind of weird. But cool. So that's all that I had prepared today. You guys can stick around if you want me to go over project 2. I'm more than happy to do that because I didn't go over that with you last week, or just answer any other questions you guys got. So you guys have a good one, and good luck on everything you got this week.
Thank you so much.
Yeah, no problem.